Cool, welcome. So that was a little bit about me. Oh, actually, that works great. Having white slides cast light out there, which means I can see you. So you know a little bit about me. I want to know a little bit about you. How many of you here are test engineers? Okay, I think that's most of you. How many of you identify more as developers, software developers? Okay, a few. How many of you are operations or DevOps engineers? Just a handful. Awesome. So normally it's the exact opposite when I talk to people. I'm heavily involved in the DevOps community, so it's fantastic to meet so many people from different backgrounds. And part of that is, in coming to this conference, I've gone to a bunch of sessions and I've learned a ton because, as mentioned, this isn't normally the type of conference that I go to and the type of talks that I listen to. And I've heard a lot about complexity. In fact, if you were in this room before, Vladek was talking about how to break things down to have less complexity. But inevitably, when you have complexity, even if you break it down, you still have complexity. You can try to make your software less complex, but it's always going to be complex. And so, for example, this is some of Datadog's architecture. This is a copy of it, actually. It's just a portion. This is what we use for development and also demos, some of our testing. And when you have microservices, as you start to break software down into little modules and then piece them together, the communication structures between them become overwhelming, right? You can't do really end-to-end or integration tests against this when things get super complex. You have to pick out and prioritize what you want to do, but to have full coverage is completely impossible. But it got me thinking about this because as someone that has more of an ops background who is used to creating infrastructure and helping others run that software, it made me think of this, that when we talk about software testing, we're really talking about production readiness, right? We're trying to ensure that the software that is written is free of bugs, that it's ready to be put out and deployed. But that's a very different thing of having production readiness from production operability and what it takes to actually ensure that that software stays running, right? To ensure that it's running in the right ways that we want it to. Simply put, there's a big difference between testing and production. I think we all understand that. And some of that comes down to the complexity that we're looking at. When we have complex systems, we don't have this idea of single root causes of failure, right? There's never going to be a single cause because you're dealing with so many other services that you're relying upon. You're dealing not only with those, but you're dealing with people and people making decisions about how that software is going to be operated. And I love this quote from John Allspaw. John Allspaw was the CTO at Etsy, if you're familiar with that company. He now has his own business where he does some consulting work. But he's been a huge figure in the resilience engineering community. Resilience engineering, essentially the engineering practice of figuring out how to keep things resilient, how to keep them up and running. And he has this blog, and this is his quote. It's actually a paraphrase of a man named Dr. Richard Cook. But the quote is that failures in complex systems require multiple contributing factors or causes, each necessary but only jointly sufficient. What does that mean? Well, it means that whenever we have an outage, whenever we have a major incident, it's never going to be because of one thing. There might be some primary technical factor, but there's always going to be some contributing factors. What was the information that engineers had at the time that caused them to take actions that combined with certain aspects of our code created the failure? Each of those individually probably wouldn't have caused the failure, but in combination, all working together, they do. And oftentimes these things that work together are the same things that we work together on to have success. It just happens to have a different outcome. And so this is why we monitor our software in production, right? This is why we want to get feedback on how things are working, because we know that it's not enough to just test our software and deploy and assume that it's going to keep functioning the way that it was when we tested it. But as I go through this talk, I want you to start to think about where's the merger between what we think of when we're testing software, when we're thinking of making software production ready and bug-free, and the things that we think about when we talk about production software that's operable. What do we need? Getting the proper metrics, understanding and getting the data from whatever we're running. How can we combine these? So as you think about that, a little bit more about me. As mentioned in my intro, I am from the United States, if you can't tell from my accent. I am a technical evangelist at a company called Datadog. Essentially, that means that my job is to help you, to help educate people, to help provide advice for how they should run software, how they should monitor their software. I also organize a few conferences, DevOps Days being one of them. There are, at this point, nearly 100 DevOps Days conferences around the world. Highly recommend that you join those conferences. They're usually very inexpensive, and I think you'll learn a lot about not only agile practices, but how different units, how developers and operations and business and even testing and QA can all work together and learn from each other. The other conference that I help run is called Delivery Conf. It's part of a conference themed around CI/CD. So a lot of the things that we've been talking about at this conference, about automating deployments, we'll be talking about at that conference. A few other random tidbits. I travel a lot. I drink a lot of whiskey. I like to catch Pokemon. So if you play Pokemon Go, come talk to me later. But beyond that, that's my Twitter handle and my email. So if at the end of this, you should be using Slido, but if you have any questions beyond that, if you're thinking about these ideas in the next couple days, feel free to email me or send me a message on Twitter. A little bit more, though, about Delivery Conf, since we are running that. That's coming up in January. You can leave the very cold here and go to America, where it's also going to be a little bit cold in Seattle. But that should be a great conference, so highly encourage you to look into that. As mentioned, Datadog does monitoring. So all of this, what we're going to be talking about for chaos engineering, requires monitoring, and we'll take a look at that. We're also hiring. So we do have a number of remote jobs. We have offices in Paris, Dublin, New York, and Boston. So all over the place. Look at that if you are looking for new opportunities. So back to the topic at hand, and chaos, and this idea of failure. Well, years ago, Netflix had this problem. They were moving from their own data centers to Amazon Web Services, AWS, moving to the cloud. And the cloud was a new thing. And as all new things, how do you know you can trust it? I mean, it's Amazon, right? How do you know you can trust Amazon? And they realized that the point of the cloud isn't necessarily that it's reliable. The point of the cloud is that you have thousands of computers that are somebody else's problem, and you simply have access to them. So you have this idea that rather than ensuring that they're making it reliable, maybe you could just provision thousands of their machines, and hopefully you can write your own reliability services. And out of this, they came up with 5 lessons, and the third was that the best way to avoid failure is not too instinctive. It's to fail constantly. How do you fail constantly? Well, they ended up coming up with a plan. They came up with a thing called Chaos Monkey. How many people have heard of Chaos Monkey? Okay, a few hands. For those of you who have heard of it, what have you heard? The myth, you've probably heard that it's this program that randomly turned servers off for randomly deleted software, right? Seeing some head nods. So that's the myth. That's actually not exactly what it was. So debunking the myth. This is from the blog post back in 2011. But the statement is that by running Chaos Monkey, which was this application that essentially did some bad things, it's as if you were turning a wild monkey loose within your data center. But if you're running it in the middle of a business day, in a carefully monitored environment, with engineers who would be standing by to address any problems that happened, that the idea was that they could learn the lessons about the weaknesses in their systems, right? They could understand failure, and then they could take those learnings and they could write software that would automatically recover from these. So the next time there was an outage in the middle of the night on Sunday, they wouldn't notice. They would just be home with their families and not even care because it would automatically fix itself. So if there's one thing that you get out of this talk, one thing at all, it's do not be a jerk. A lot of people hear about this idea of chaos monkey, that we should write applications that break our systems just to test the resiliency, and that it just does it randomly. If you do things randomly, if you're destroying your software, if you're taking down systems without telling your colleagues, without planning things, without following the guide that I'm going to share, then you're going to be a jerk. Don't be a jerk. So how do we do it? At Datadog, we like to call them game days. They're fun. We take some time and we make a game of it. So we call them game days, just like a football game. They last 90 minutes, right? So you want to set out, when you're doing a chaos test or a chaos experiment, you want to set time limits on it. Because if it runs all day, then your manager's never going to let you spend all day playing around. And also, if it takes too long, nobody really wants to do it. So 90 minutes, just like a football game. Everybody likes to play football. It's really fun and short. 30 minutes of that is spent planning. Because again, nobody likes to spend a long time planning. So we want to keep that as short as possible. We do 30 minutes of planning. We do 50 minutes of playing. So 50 minutes where we actually can run our experiment, where we can start to intentionally destroy our systems to learn about them. And then just 10 minutes to report. Because again, if it takes you a long time to report what you've done, that's boring. Nobody wants to do all that reporting. So for that 30 minutes, the beforehand, that planning, how do we do this? Well, we first need to schedule it. Right? Again, if you're doing this without scheduling it, you're doing it on your own and not telling anyone, well, then you're a jerk. So number one, you have to schedule it. Number two, you have to pick your tests. How are we going to destroy our systems? And I'll talk about this in a bit, the process we go through, but you need to pick those tests, and you need to start easy. And this is the most important of this, though, I think, is to write down what you think will happen. Form a hypothesis. You are now a scientist, and you're going to use a scientific method. So you're going to create a hypothesis. What do I think will happen when I destroy this bit of software, when I turn off a service, when I take down part of the network, right? Allows you to think through, what do my systems actually look like? How can I expect things to happen? Other important thing, though, is write down what you expect to do if everything goes horribly wrong. As mentioned, we work with complex systems. You might be testing one service, and you think that there's only one other dependency, so that's all we'll see. And then you quickly discover, oh, there's another team in this organization that's calling that API with a service that nobody knew about, and we just took them down as well. So you need to have a plan B, just in case. I personally have taken down Datadog, at least our staging. I was making a small text update, and I deployed it, and it turns out that I had forgotten to rebase against master and pull that in, and so I deployed and I reverted a bunch of changes. I took down our staging. And while it's staging, and that's more or less safe, I had all of the engineers at Datadog, about 150 at that time, really, really angry at me. So you want to have a plan B, right? Just in case things go horribly wrong. And lastly, also super important, is you have to share this. Not only to your team, not only to the people that work on the same software that you work on, but across your engineering organization, as far as you can. Right? You want to share this because everybody should know what's going on. Again, if you happen to do a chaos test and you take something down and it affects their systems, how would they know unless you share this? So share this information out to everybody that you can. Let them know when you're doing it. Let them know what you're doing. Now when we're actually doing the playing, we want to start in a safe place, so we will start in staging. You don't want to just go and break things in production, but eventually you'll graduate there. As we do these tests, as we break things in staging and we realize that we've resolved things so that they fix themselves, and obviously that code gets promoted into production, we'll want to take those tests and ensure that those tests work in production as well. So we'll start in staging, we'll move to production during our off-peak hours, the times when our customers may not notice if something does go wrong, and then we'll promote that into prime time. So during the middle of a business day when we have heavy traffic, that's when we'll run the final test. As we start to do this experiment, we'll first announce that in group chat. We like to use Slack, but if you use another chat service, that's fine. But the idea is that you want to do this in a place that people who are not in the office can see it, right? Doesn't matter if you're not distributed, because someone might go out to smoke a cigarette. Someone might go out to get an espresso. They come back, everybody else might know that you're running this test except for them. So do it in a place that that information is saved. Your chat tool like Slack or whatever you're using is the best place to do this. Get used to incorporating that into your communication culture. Then maintain those group discussions there. Right? It's really easy, again, when you're in an office to turn to your colleague and say, hey, this is what I'm seeing, or this is how our software is reacting. But then there's no record of that. And if we want to keep our planning really short, well, if you go into that 10-minute planning session and you're trying to remember everything that you said to your colleague and that they said to you and then write that down, that's going to take more than 10 minutes, right? But if I have a chat tool, I can simply cut and paste or put a link to Slack to that particular message. So make it easy on yourself. Keep everything within your chat tool. Next, monitor for outages. Whatever monitoring system that you're using for production monitoring, ensure that you're monitoring all of your systems. Because if you're running these tests and you're not using any monitoring, then you're not getting any data. That means you're not going to be learning. Finally, you run the tests and just ensure that you're taking notes. Take notes of everything that you see, right? Because again, the whole purpose behind this is to learn. And once you have those learnings, then you could build those resilient systems. Finally, the after. This is the 10 minutes in the end. Really simple. We want to keep this as short as we can. So we create tickets, whether we're using whatever project management system we're using. We use Trello. If you use Jira, if you use whatever you use, ensure that you're creating tickets to ensure that those jobs, those tasks that you want to accomplish get done. Because as we all know, if it doesn't exist in a ticket, it never gets done. Write down the key summary, key lessons in summary. Right? So we want to ensure that we're taking that summary, we're taking that information, we're summing it up, and then we're going to send that out. Again, because everybody should learn from this. Right? Not just you and your team, but everybody within the engineering organization can learn from how we've built our software, how we've tested our software, because they probably are doing some similar things. And then probably the most important thing is to celebrate. After all of this, celebrate, right? Let's say you run an experiment and you do it in production, you take down all of production, you have many angry customers, they've all emailed support, and everybody knows that it's because you ran a test. Well, fix that first. Don't go out and get a beer. Fix it first, but then celebrate, right? Why should you celebrate taking down all of your production systems? Well, you found a critical flaw. This flaw could have been found by a malicious hacker. It could have been found by a corporate enemy. It could have happened in the middle of a holiday when traffic was 10 times higher. Celebrate, right? You found this problem and now you've been able to address it. You know the critical weakness in your system. That's a good thing to know. You should celebrate that. Similarly, if you run a test and everything goes perfect, it's according to plan, you have all the monitoring on your systems, everything's super smooth. Well, that's a good reason to celebrate. You're a fantastic engineer. You did a great job. So you should celebrate either way. So I did mention those tests. How do we pick those tests? At Datadog, we have a number of levels. The first level, level 0, is we terminate the service, right? If we have a service and it goes down, it should automatically restart. Pretty simple. If you have services that it goes down and it requires some manual intervention, someone needs to plug in some credentials, or they need to log into a system and do something beforehand, that's not ideal. So level 1, simple test, turn it off. Does it turn back on by itself? Also, at this point, we'll try to block access to one dependency. Right? We'll want to ensure that things actually behave the way we expect them to. Now, it may not necessarily survive when that dependency is turned off. It may generate errors, but at least we want to ensure that we have right monitoring on it, that we know that things are going on, that has good error reporting, that it acts in some sane way. Then we step it up. We block access to all the dependencies. And again, your service doesn't have to survive. If this is a web store and you turn off access to the entire checkout system and the catalog, and people go to the homepage and it's mostly empty, well, that's fairly reasonable. But again, do you have monitoring on that? Do you know, is this system or is this service complaining that it can't reach any of its dependencies, right? Pretty straightforward. The next is that we terminate the host. So at Datadog, we run on Kubernetes. Kubernetes requires underlying hosts. Theoretically, if we turn off one of the hosts, Kubernetes should take that container and realize that that host is gone, and it should restart that somewhere else. So if you're using containers, if you're using Docker or Kubernetes, test that out. If you're using VMs, you should still have something in place. If a virtual machine dies somewhere, it's a virtual machine. It should get restarted. The third level, or the fourth level, because we index by 0, is that we degrade the environment. So this is where things start to get really fun, and this is really the point that you should be aiming for. Degrading the environment means what happens if we max out the CPU or if we take up all the memory? What happens when we degrade the network so that things can't communicate consistently or properly with each other? These are things that happen in the real world when you move to the cloud and you're no longer controlling your systems. But it also happens when you are. It's just usually when you are, you have a little more insight into them. When you aren't and you're in the cloud, you're relying on Microsoft or Google or Amazon. And so you want to test these things out. But the other main reason that we want to shoot for this is the time when we can actually pass off our on-call duties. So at Datadog, if you write software, you are responsible to run that software. That means you are on call. If your service goes down, you get woken up in the middle of the night for it because you're the person that wrote it, you know the most about it, you're responsible for it. You write it, you own it. A lot of organizations have this role called an SRE, a site reliability engineer, or they have ops engineers, or they have DevOps engineers, and these are the people on call. And some software developer writes some code and they pitch it over, and some ops person puts it on a server and runs it, and now it's the ops person that's on call. And what happens? Well, that service goes down, and the ops person gets woken up in the middle of the night that the service is down, and they say, I don't know what this is. And so what do? Well, then they try to call the developer. Hey, what's this service? That's not too efficient. It makes people very angry to get woken up only to have to call another person. So we have software developers own things, but at this level, when we have proper monitoring, we have good alerting, we ensure that we have playbooks, it's the time when we can actually pass that off because we've ensured that this service is fairly resilient. If it went down, it should automatically restart. If alerts were thrown, there was proper monitoring and it had some sort of next steps that the ops engineer or our SRE team could follow. So this is at the point when that developer can say, hey, SRE team, you can now help out with on-call, which now means that the developer has some nights back. They can sleep easy. Beyond this, we start to get a little more difficult. So then we spike traffic. So at Datadog, we have thousands of customers sending trillions of metrics every hour to us. It's a lot of traffic. So we'll ramp that up and see how systems handle it. What happens when your systems get 5 times, 10 times, 100 times the traffic than you were expecting. And then nuclear holocaust, all-out war, everything is dead. Terminate the region or the cloud. This is the ultimate goal for everything. At Datadog, we're multi-cloud, so we use a bunch of different cloud providers. The goal here is that if for some reason Amazon went completely dead and they were completely gone, could we migrate to Azure, right, so that none of our customers were affected? Or could we migrate to Google or to any of the other clouds? So I've given you a ton of information, and it's also mid-afternoon, and I know some of you are sleepy because it's dark there. So let's have an experiment. Who wants to do this live? Yay. Hey, we just want some coffee. We're sleepy. Okay. So Who here knows Kubernetes? Just curious. All right, not too many hands. That's okay. I like to tell people that Kubernetes is just like magic VMs, which, I don't know. Some people laugh, some people think that I'm an idiot. It's probably the latter. If you don't understand Kubernetes, you don't really have to worry about it. All you have to understand is that a container, or in this case a pod, is similar to a server, right? So let's see, let's clear that, and also let's make it a little bit bigger. Right, so I'm gonna query for the pods. Again, pods are essentially in this case like servers. What I've got is Datadog, which is my monitoring. I've got WordPress. Are we familiar with WordPress? Yes, maybe. If you're not familiar with WordPress, it's a PHP blog software. So essentially it's PHP and MySQL. So MySQL, I'm assuming everyone understands, is right here. So I've got essentially a PHP web application and a MySQL database. Pretty straightforward. Let me show you what that looks like. I will come over here. I've got this website. Let's refresh that just to make sure it's running. Yes, it refreshes. Welcome to my beautiful website, Chaos at TestCon. It's just a standard WordPress blog. I've only updated the front there, but you know, it's pretty basic, right? So let's start with that level 0. What happens if we turn things off, right? So let's try that. In Kubernetes, as mentioned, I've got these pods, so I can say something like delete pod. And this will essentially delete, oh, actually, I'm totally skipping ahead here because you showed me the sign that I'm about my time, and now I'm all concerned about that. Let me jump back. We have one more thing that we should be going to. It is here. I totally forgot the steps. Planning. We're supposed to do planning. Scheduling it. We're doing it now, and I'm running out of time. So let's do some tests. My first test, let's kill MySQL, right? Pretty basic. If I were to kill MySQL, again, I told you this, even if you don't know what WordPress is, it's a blog, it stores things in a database. If I delete that database, what do we expect to happen? Someone shout something out. Site's down. All right, cool. What do we expect to happen? Site goes down. Cool. What might that look like? Maybe I should get some sort of page with an error on it, right? 404. All right, so get a 404 error. That might be possible, you know, page not found. Although it's probably going to be more like a 500 error, right? Because there's some sort of, it's not really that the site wasn't, or the page wasn't found. Okay, cool. Those are some good ones. We'll actually step up this test a little bit more, and let's immediately advance to degrading the environment. So there's a few other things that I'm going to run. What do you imagine would happen with MySQL if I just maxed out the CPU on MySQL? Any thoughts? I heard timeouts and slowdown. All right. Great. So if I max out CPU, it'll slow down or time out. All right, and the other one that I want to, hopefully we'll get time for this, we'll try to max out the memory. So if I, similarly, if I have MySQL and I eat up all the memory so that MySQL doesn't have any, what do we expect to happen? Sorry? Get an error? Yeah, all right, sure. We should get some sort of error. Maybe you get an out of memory error. Cool. So we've done most of the planning. What are we going to do if things go horribly wrong? Well, this is a conference talk. I'm not going to fix this. I'm pretty sure that there's places out there, so I'm just going to go out and get a beer. I invite you all to come with me. If things go horribly wrong, we're just all going to go get a beer, right? That sounds like a great plan. And then I would share this. Well, you're all here. You've all seen it, so consider it shared. Easy enough, right? We've done the planning. It's not difficult. We managed to cruise through that So let's actually jump back into this and, all right. So the first thing that I was going to do, I was going to delete the service, right? So, or delete the pod. So if I go ahead and delete my WordPress here, my pod, what do we expect to happen? So I've deleted that. I'm going to jump back to my website. I'm going to hit refresh. Oh, hey, it's hitting refresh. It's still there. Is it cached? Nope. I'm holding down shift and refresh. So one of the fun things, since most of you don't know Kubernetes, but if I actually get my pods again, well, it looks like it's back up and running, but we'll notice that the hash here is different from the hash there, right? So one of the cool things about Kubernetes, and for those who don't know Kubernetes, you've heard that it's hot, you've heard that it's this amazing technology. This is one reason why. We can see that 23 seconds ago, it just restarted things for me, right? So that's a cool thing. Let's go ahead and throw that into our notes. Things we saw. So first off, we deleted the pod, and it restarted. Awesome. Great. So we have pretty good software there. The other thing that we were going to do was that we were going to delete the deployment. So in Kubernetes, there's the idea of a pod, which is, again, similar to a server that's running, but then there's the deployment. And the deployment is essentially the specification that you want X number of these servers running. So in this case, I told it, Kubernetes, I want one MySQL server running, and it ensures that that happens. But what if I actually delete that specification? So let's kubectl delete deployment WordPress MySQL. So this time it should stay down, and actually if I get pods, I can see that it is terminating. So I will jump back into here. And what happens now? Hey, there's that message that we were expecting. 500 error. Can't establish the connection to the database, right? The other thing that we want to make sure for, right, again, is we want to make sure that we have that monitoring in place. Do we actually have monitoring? Looks like yes. So that was green before. It is showing that like my MySQL deployment was deleted. All right. So we're quickly trying to run through these. If I do kubectl, shoot, I am in the wrong directory. Projects, chaos, demo, Kubernetes. Cool. So that will start MySQL again for me. And it's up and running, just like that. All right, one more thing that we wanted to do. Since we're running out of time, who wants to max out the CPU? Nobody? Who wants to max out the memory? All right, that was a few more people. Man, you guys are so sleepy. All right, it's okay. We're getting towards the end of the day. So if I go back to this, what are we looking at? We are going to max out the memory. And what did we say we thought would happen? We thought that we would get an out-of-memory error. So we've come up with the hypothesis of out-of-memory error. I'm going to kubectl exec ti into this one. So essentially, the command here that I'm running is going to run bash on the remote machine, where I have this wonderful tool called stressng. StressNG will allow me to stress out really any of the systems, so CPU, memory, I/O. So I'm going to copy that one, and we're going to do it for 60 seconds. So let's see, where is that? And I don't need those backticks. So really here I'm just telling StressNG, which is a fantastic tool, that I'm going to have two memory eaters. They're going to take up 4 gigabytes, which is all of the memory in my system here, and it's going to be for 60 seconds. So let's run that. It's dispatching it out. If I go back to my site, let's see. Well, that will probably sit and spin. So that's fun. One of the other cool things, though, here is, let's see. Oh, so I'm actually not reporting any pods. And this is the fun thing with Kubernetes. If I, let's see. Let's go take a look at this and update our metrics. So you can see that the load average here is spiking. And then I'm getting white space. That's interesting. Yeah, so I'm no longer reporting metrics. So let's go ahead and make a note of that in our notes. What did we see? Things we saw. System load spiked, then stopped reporting. And if I jump back to kubectl, unable to connect to the server, TLS handshake timeout. So one of the fun things here, and I will skip to the end, is that when you eat up all the memory and you happen to be running your Kubernetes master on the same node that you're running all of your Kubernetes workloads, eating the memory means that you're not only starving MySQL here, you're starving out Kubernetes itself, which means that everything that's running on it stops working. Yeah. So for those who know Kubernetes, you should look into pod priorities. For those that don't, just be aware that Kubernetes is not the magic thing that you've heard about. It still exists in the physical world. So that is one of the unexpected things. So I'm going to cut and paste that. Things that we didn't expect. Cool. Things that we should fix and change. Again, for those who know Kubernetes, pod priorities. All right. So that was the actual running of the experiment. And again, we want to keep the reporting super, super fast. So things we should fix or change. Set pod priorities. Write a summary. Amazing thing is we have it right here. We can just copy and paste this. So we're going to copy and paste that. We're going to share it. So again, you're all here, so you can see it. I'll be tweeting out about this later. And then finally, the last thing is to celebrate. So yay, thanks for giving me those wonderful hypotheses.
Thank you for your talk. And do we have a question from the audience?
So before we do that, I've got a few more things, additional resources, if we can get me back up on the screen. Can we? Yeah? All right. So the one thing that I do want you to take away from this is it doesn't require any special tools. It really just requires the process of planning it out, coming up with a hypothesis of how you think your systems will react, and then executing on those, and ensuring that you have the data so that you can fix your systems. So you can use simple built-in tools, systemctl, kill IP tables. These are things that are built into systems that allow you to kill processes or mess up your network. A few other things though, Comcast is a network tool that allows you to mess with your network. Vegeta is a load stress tool, allows you to generate huge amounts of traffic to your services. And StressNG allows you to max out CPU, memory, disk I/O, things like that. A few other tools, Gremlin is a company that I've been working with. We've been doing some workshops. They do chaos as a service, so they make it super easy. You should check them out, and Chaos Toolkit as well. All right, and with that, we'll go on to the questions.